Yes. So, icebreaker, little survey. Put hand up if you consciously use AI. Emphasis on consciously. And hands stay up if you regularly use ChatGPT. Today, 10 minutes ago, because it's currently down. And who has like an API key, for example? So don't need to explain too much, but I have a slight confession to make in that this, when I drafted the proposal for the talk, I was thinking basically the open source models will massively progress in like the next, it feels like a very long time, but it's not, the next X months or so, and I shall demonstrate, inferencing them with, whatever I happen to have on the stage, and that basically hasn't happened. So I've, despite forgetting to change the description of the talk, I think the content of the talk is effectively going from gritty technical stuff to more sort of soft philosophical stuff about what the existence of language models, but imperfect language models, actually means for us as programmers. Also, I just think that picture's funny. Basically, the only kind of bit of jargon that I think is actually needed, because it's not a theory or even necessarily a implementation talk, is effectively the term large language model, which for our purposes you can view it as a giant blob of maths, just for predicting the next token in a list of tokens, which can be, like I've just downloaded a few of them. It can be anywhere from basically the size of a small USB stick to, say, if depending on who you believe, OpenAI, their work could be anywhere from a hard drive to a whole rack of many hard drives. There's a lot of shades of grey in terms of what you can actually practically mean, and it's not about I don't really want to talk about their design, partly because I'm not an AI researcher, but also because they're so astronomically difficult to train economically that it doesn't really matter for the purposes of the things I actually am interested in. But there's a framing question in that we're not AI researchers, but we are programmers, but we also build things for people to pay us money, hopefully, and produce value. At the end of the last talk, for example, there's a question of is a neural network of any kind, or even a computer of any kind, or any deterministic, even if you somehow inject a bit of randomness in there, algorithm, whether it can actually be intelligent. But I don't think it matters because they might be useful. Is the rub. I've mentioned the term compression here, and if you've overheard a bunch of us talking about this downstairs, it's just that there's a lot of industry focus on compression, or rather. So, for example, there's a quite famous prize where you can win money for just getting like a fraction of a % better at this point on compressing Wikipedia on the basis that it's a very attainable goal, which might be a useful heuristic for some kind of intelligence. So, in a ideal world, if you set the problem up right, to be able to compress Wikipedia, you might have to have some kind of semantic understanding of what the text actually means in theory. But it potentially doesn't actually matter to us as programmers because because they're effectively just another arsenal of tools, whether they're intelligent or not, or whether they're good at compression or not, unless you actually want to use them for compression. And this is one thing that has dawned on me recently, is that all of this AI stuff has been brought about basically by, at very least, people who are writing code and programmers. But I think a lot of the value and the treasure you can find by using them is actually often not in the same patterns that programmers like to exist in. So, for example, I think some of the most interesting things I've heard about people using AI have been people who either are learning to program, or people who wouldn't even dream of ever programming. And I think this is an important thing to internalize, because you can look at it, these tools, as just a thing where, oh, it can write code for me, and they can. They're getting, in some places, frighteningly good at it. But as programmers, if we want to integrate them into systems, it might require a different way of thinking about how to actually use them. And they, obviously, you probably, if you either young enough, have children, or just read the news, some of the most interesting things I see are basically people using these AI tools to. I've put a strike through this, so that, so it's not libelous, but potentially cheating on their exams. But even if they don't realize that they're inadvertently shaping the kind of they are the next generation, they'll probably look upon us as idiots who don't understand the way to effectively use these tools. And I find this mildly interesting. If we do some kind of so basically like technical analysis, if you imagine the sort of the classic hype curve, we're either on it in the sort of we're past the hump going down, or it's currently school holidays in the West. Make of that what you will. Both can be true. Both can be interesting. It doesn't really matter. There are a lot of really. Hello?
Just to be clear, the diagram is, I think, GPT usage numbers, right?
Oh, sorry. It's the Google.
Oh yeah.
Just Google search trends. I don't know how reliable it is as well, but the average. If you go on like Statista and look for the data, I don't know where they get the data from, but the data they have on the age distribution of people using ChatGPT, the bucket that starts at 18 is suspiciously large. So there's presumably a bunch of people who aren't 18 yet being lumped into that one. I think that's where this pattern. I was trying to see if there's any data from somewhere in the southern hemisphere that I could look at separately, but I couldn't find any, or at least I couldn't easily find any. There are a bunch of things where you can immediately see these really tricky, weird, fuzzy problems which these things can potentially solve. So for example, during the Linux distribution talk yesterday, it struck me that you could, in theory, have a AI watch your bash history and work out how to kind of prettyify you trying to like hack together something that your build system doesn't like, but in a way that you can actually reproduce it. And if you had a transactional system like proposed in that talk, you can just go and try it, for example. But that doesn't actually mean we can actually do that today. It's a bit like saying, oh, if I had an identical version of myself embedded in the computer, then he could probably go off and do something for me. But the interesting thing, I think, is that there are a lot of things which are very tricky, but almost possible, and that they require a bit of help, but they're almost possible. So this is probably familiar to everyone, but there are basically, in terms of the models you can readily access programmatically, you basically have a choice of the OpenAI models, i.e. ChatGPT, and a smattering of open source ones. There are a few other things which have APIs if you pay them a bunch of money, but for the purposes of my slides, I'm saying this is what it is. And the kind of the hubristic delusion that I had when I proposed this is that the open source models without being effectively improved on an individual task, would be much better by now, and they're not, hence still a bit crap. But you can see, and I can potentially demonstrate at the end, they are already for an alarmingly small amount of data, very, very effective at sort of babbling like a baby, in a good way. If you consider, for example, stable diffusion, which isn't the same architecturally as ChatGPT, but shares some insights. I don't know how big the kind of a cutting edge blob of like stable diffusion weights is, but it's not very big, and you can get all of that content from it. There's an element of magic there. And one thing you may have seen is there's a new Facebook of open source, a new coding model recently called Code Llama, which is getting there, but is nowhere near as good for the things I'm about to discuss as, say, ChatGPT. And a specific example, which I think I got the idea talking to Attila potentially, is that if you imagine every tool, basically with the exception of import C, because it's a slightly different way of thinking about the problem, but if you imagine when we want to bind with C and C++ libraries, you'll hit a wall where you have to translate by hand. The tool basically, without having 1,000 special cases embedded, it can't translate these. This is a relatively simple one, but like C programmers love doing these completely idiotic it's true. They love these like idiotic macro patterns, and we can immediately see. That's not a pun. We can immediately see what we need to do to translate it, but actually programming a computer to do it, unless you get either very clever or have big or are extremely patient, is very hard. But it's the kind of sort of slightly fuzzy, roughly linguistic problem that you'd expect an AI to be able to do, and they can, except they need some help, which brings me on to the next thing. So this is if you just ask ChatGPT to do it, you'll end up with something. One of the things that it gave me is this, and you can see it's basically gibberish. If you imagine we're replacing effectively just that expression or expression to be, because it's in the preprocessor. But it's like object.toPullOff alias. It's gibberish, but it also knows most of the pieces are actually there, which I think is a very good start. And the thing is, if you give it feedback, because you can question.
More of a comment. I've been struggling with this problem with import C, and currently import C only handles trivial macros. But if you go back to the macro, you see it's obj.field equals set. What does that look like? It looks like a statement. Okay, and I haven't implemented this, but I realize that what the compiler can do is try to parse it like, is this a statement? Does it fit the grammar of a statement? And if it does, then you can translate it to a lambda, and set by name is a lambda that does that, and it should work. And you can, does this parse as an expression? Does this parse as a function? And that will take care of a large number of those macros, but a much more intractable problem is one like the hash begin open curly brace hash and the close curly brace, the macros that sort of have an unparsable or an incomplete syntax to them that you need multiple macros to build up that one. I don't know any way to solve that problem, and I don't know how an AI could solve it either, because it's not a self-contained problem, because it's distributed over multiple macros.
Honestly, ironically, I would expect an AI to have a very much easier time with begin and end, because like AIs are very good at skipping irrelevant details. Unless you're doing something evil like define begin closing bracket, it's probably just going to see begin, and it's going to be like, it's going to figure it's going to be an opening bracket. It wouldn't even have to look at the actual definition to figure that one out.
One thing that can help both with AI or any other, like it's effectively old-fashioned AI. If you start guessing by just seeing what it passes like, which we should be doing. But one thing you can do as well is if you're lucky, you'll have context to look at, so you can potentially see the pattern. And one thing I'll get onto is that if we completely restructure the way we actually look at the problem, we can potentially get the absolute maximum from the tools we have available more easily. So if you imagine at current rates, the models we have available to us are improving without making a prediction, but they're improving. So you could just wait until it can just nail this first time. And, we get lucky, and OpenAI starts scraping. I don't know. Start scraping every Dub project or something like that. Maybe we could bribe them for. But it's something I've been thinking about for a while. Is if you imagine there's a lot of like fuzzy details which are difficult to in a kind of complexity sense, they're very difficult to solve, but they're quite easy to check. So maybe we just need a more interactive way of doing this. So, for example, I don't know how well it would work for import C and DPP, but if you imagine if you're generating C bindings with a tool like dstep, maybe you should just be interacting with it as it goes, because you often have to fix them up anyway afterwards. And one of the things with these the more recent approach to AIs where they're instruction driven is that if it interprets the instruction sort of 80% of the way there, you can often give it either very direct feedback. So, for example, if it doesn't quite know a programming language, but it knows how to program, it has some intuitive notion of how to glue Unicode together in order to make a computer do something. You can give it a specific thing, and it will be able to often able to interpret your instructions, saying, "Oh, just put a semicolon there." But also, you can just say that's wrong, and it might be able to guess its way through that. If you were tomorrow going to do this with some kind of AI tool, you're also probably going to the energy costs of doing it are actually very high, so you probably want it to be interactive anyway. But with regard to changing the way we actually approach this kind of tooling, I think you can make an analogy with the work around driverless cars. And cars in general, for example, if you have a problem which is sort of half social, there's a bit of technology in there. Can you trust people? Things like that. You can, but say for now you're a paperclip maximizing evil AI, let's say, and you want to just make driverless cars work. No one should ever need to drive a car again. Which I don't think that's a good thing. But if you just suppose for now. You could either work really, really, really hard on the road network, on the car, or you could potentially change the road network to make it more easy for the cars to work, if you're sufficiently incentivized to do it. So we can potentially extract a lot of the sort of the slightly murky, because it's a new field, treasure more easily just by being experimental enough to try new approaches that fit more with the kind of the unearthed power that we're trying to harness, which I think used to be something of a goal in the past. If you imagine, if anyone's ever written raw tech, rather than LaTeX, but raw tech, you notice that a lot of the commands and error messages very much form a dialogue with the computers. That could well have been what Donald Knuth had in mind when he was coming up with it. And on some more practical stuff, even though I don't think it's that interesting, to be honest. Prior to effectively sort of the AI explosion at the end of last year, you had a very kind of big tech and academic-dominated field of software, where things are very, very clunky and often churning quite a lot, because people need new things to do research with. So, for example, running import torch in a Python script on my laptop to this day. So importing PyTorch is, it's a common deep learning library. It takes 1 second just to import it, and you haven't even run any code at that point. Whereas spurred on by all this kind of AI boom, you have a complete vibe shift towards the kind of more traditional kind of hacker archetype, where people who actually know what a memory map file is swooping in to avoid massive amounts of overhead. So the case in point being it's called llama.cpp, but the bulk of the code is actually a C library, which is specifically special case just to run the Facebook llama model, but has been successful enough that people have sort of glued other things into it. And even though it might be asymptotically worse than a lot of the other offerings, because systems programming languages are very good at this kind of very, very direct task, it's much faster and the latency is much lower than the things that has effectively displaced. And luckily, because we have 20 years of work in talking to C and C++, it's actually very easy to make it work, with the exception that I think on this laptop you won't be able to import C it, because the preprocessor, I'm describing a bug report. The preprocessor thinks it has Neon, the ARM SIMD instruction set enabled, which will then enable 16-bit floating point types, which import C doesn't have, although D should have, and will need to have in the future. And Speaking of PyTorch and the kind of very large big tech, PyTorch is basically a Facebook invention as far as I'm aware, and Google's thing is TensorFlow, and they do very strongly reflect the styles of the two companies. As things don't just need to scale, but actually need to perform well at every scale, there are a bunch of kind of old established techniques, so basically compiler optimizations being needed to make these AI models go faster. So that might be too small, but if you this is it from PyTorch, where they have a very standard kind of compiler engineer's old favorite common sub-expression elimination algorithm, which they need to make the models run faster when they ship them off to either a CPU or primarily a GPU, because it isn't good enough just to be able to have a very flexible library that you can just throw 1,000 GPUs at now. It's actually there's actually very real economics here. Which brings me on to, I think, this field where it requires a bunch of very different styles of programming and thinking in the same project or product. So you want like a very clean kind of Python-like experience in specifying the model, but you also want to be able to do your own memory allocators properly and know exactly which SIMD instructions you're getting, and I guess Nicholas is here, so also write GPU kernels nicely. This is something that I think D can do extremely well. Because I think we have a very nice language for doing that kind of thing and keeping the complexity on track without having to use. I don't know how many. There'll be at least 3 languages on the go inside like the main PyTorch library, for example. Whereas we have I think a unique gift for combining the best of quite a few different approaches in a people-friendly way within the same project. So basically, we need to do a machine learning library, and there are there's stuff to use that already exists. There's a library called Grain, which seems quite promising, and Vladimir has done one, but I think they're either solving a specific problem, which might be slightly too, isn't necessarily general enough, and also just sort of nitpicks I've found with them. But I think next DConf is when I'd quite like to have something general, because the idea with this one was really just to rush directly to just the things you need for language models, but I think that would have been quite silly. Whereas I have quite a clear idea of how we can do this really well, and I don't have an ending slide, so that's basically ramble over. But please ask questions.
In the Python world, one of the things that they were able to build upon that helped them move very quickly is there's another library called NumPy, which takes care of all the matrix and linear algebra processing, and it converts it into CUDA instructions to run on an NVIDIA card, all that stuff, and it makes building things like PyTorch much faster because you're building on something that's already been highly optimized. In D, is there an equivalent of that yet? Can the mirror library do that, or are you familiar with anything that's really good at optimized linear algebra in D?
Well, I mean, last time Ilya benchmarked it, at least Mir was faster than NumPy on quite a few things. But I don't know if that's. I can see that being true when these libraries were coming about, but I don't think I would imagine that PyTorch, for example, now can work without a NumPy dependency. You basically have to roll quite a lot of this yourself, because a lot of the problems aren't just doing the operations. You have to build a lot of scaffolding to be able to provide both a programming API for the models to be expressed, but also you need a bunch of internal APIs and knowing what not to expose in an API, such that you can, for example, if you specify a model as a whole bunch of it's basically a graph of operations. You want to be able to do optimizations on it. So in terms of the actual total amount of work you have to do to get impacts quickly, you'll want a fast linear algebra library, which we have, but I don't think it's actually what stops things like that. It's like there's already a Mir-based automatic differentiation library. I mentioned it just now. It's called Grain, and I think there's Grain 2 as well. But I think I couldn't get it to work last time tried it. So basically, the short answer is yes, and also it's and the longer answer is it's complicated.
Okay, talking about this sort of, as I understand the way PyTorch works, you're feeding in data in a given format, and you sort of in Python in the background through the operators you apply, or even through operator overloading, where D could have some advantage, sort of builds up this graph of the actual operations that are being performed, and that then gets compiled into whatever backend you're using. If you've been playing, like if anyone has been playing with this sort of stuff, I think one of the most common experiences is I tried to run this and it crunched for a minute, and then it gave me an error about the matrix sizes not matching up. It feels like this is something where something with a strict type system should be able to have an advantage, like being able to declare variables that actually state what data format this variable is expected to be in, and have that be type checked across operations. Does it seem promising?
Yes, and you also basically want dependent types. Which obviously you're buying into a lot with that, but I think there's a Scala library which gets quite a lot of the way in terms of the ergonomics of having a dependently typed system for checking the operations you're doing. But yes, although when I've been fiddling around with this stuff, I actually tried to keep the typedness of the API quite minimal, because there have been a few things where without commenting on specific things about people's work who aren't here, there are some patterns where you can basically try and be too D for your own good. It's a bit like everyone C++ after working out, unless you have extremely perceptive taste. Everyone C++ after bumping into the way the STL is written, for example, you can try and do too many things, or I'll try and do this at compile time. It doesn't actually matter, but you effectively buy into a bunch of decisions that you can get stuck with. But it is a very real thing where, despite the ostensibly extremely fast development model that you might subscribe to with Python, the systems they have are actually very susceptible to weird things breaking halfway through, or massive complexity, leading to poor performance, and thus throwing away any feedback you had. And I think people basically know this now. I think anyone who has a independent of their whatever their use of PyTorch is, programming background, I think will have pretty strong opinions and experiences of how they would improve it. But it's obviously very difficult to do, because it's a very extremely quickly moving field.
Question from the internet. Serg is querying what the status of auto diff is in D.
Depends on what you want. So one thing I would quite like to do is, does everyone who knows what a dual number is? Or like for forward mode automatic differentiation. So basically, by designing something that is algebraically a little bit like a complex number, you can just do the operations, and then as long as you set you have in a programming terms, a struct of two numbers, and then you just keep track of the derivative next to the number. And then as long as you basically set the derivatives at the beginning of basically the bottom of the tree right, by the time you get to the top, you'll end up with a number and another number. And the first one will be the calculation you're interested in, and the second one will be the derivative of what you calculated, provided you've done nice things. And that kind of programming is easy to do, but there are other techniques which are much more complicated. And speaking of complexity, there's a mere library for doing it called ediff, which I don't think there's any documentation for, but it will actually build the expression tree at compile time, and then propagate the derivatives backwards, allocating the memory statically because you've done it at compile time, which is very, very actually does seem to be quite good for a lot of scientific problems, but it depends, because there's very different scales involved. And if the type of automatic differentiation that you would want for, say, you might want for a physics problem might have a handful of parameters, and you might be interested in, say, you can actually do this. You can run like a fluid simulation and calculate the derivative of an individual part of the simulation with regards to the starting parameters, depending on what the simulation is. But if you have a machine learning type problem where you might have the order of something like 1 billion things to wiggle. You need a very, very different style of programming to be able to capture the yeah.
Looks like we have 2 questions left.
Yeah, Max, thanks for the talk. Just a comment and then a question. The comment being, I completely aligned with your notion that D is an amazing fit for this, in that it spans from the basically Python-esque type stuff all the way down to the metal. So I think we have and also the metaprogramming stuff, very, very important in this area, I think. So very excited about that. But the question, I guess, is where do you see the problems in basically bringing us forward? What areas need focus? I have a couple in mind. The types that you talked about, the various reduced precision types and things like that. You've mentioned a few, but I was just wondering if you could kind of give a highlighting of where you think the effort needs to go, or do we just need to explore it a bit to find our way?
I think the current state of affairs is very much such that we'd be primarily limited. Like if we started and failed, it would be on us rather than our technology. But I think one thing that does come to mind quite frequently is when you start leaving the prototype phase, or rather in a performance sense kind of prototype phase, when you want to start doing interesting stuff, where you want to be able to cleanly use every bit of performance the machine has on the CPU or potentially the GPU. That's when you can the aspect of D where you have 2 compilers, even just from a kind of developer onboarding perspective, can get quite ugly, and that there are a bunch of things where, even though like DMD performance isn't an issue, but with say LDC and GDC, they both have slightly different or completely different, or sometimes the same but with different names, way of accessing the shiny stuff. So for example, if you want to emit the same code multiple times for different architectures inside the same binary. But the specific example I'm going with is if, for example, you have you're going to ship things to machines that some have AVX 512, for example, or some have like weird dialect of AVX 512 that doesn't quite have the instruction you want. There's a GDC-ism for emitting the same code multiple times with a different instruction set, as long as it's still x86. And if you want to use that, you get locked into things. So every goal is like weird version this, version that, effectively C build system style kind of preprocessor hell, but in D.
Yeah, you talked about compressing Wikipedia. There's actually a project already to do that called OpenZim. So basically, it deduplicates the articles and compress it with Z standard or other algorithms, and you can actually do Z standard maps. So you can train a data set with common words on Wikipedia to make compression better. So what would be the use of AI in that sense to compress Wikipedia better?
Do you mean what would be the practical benefit, or to a researcher?
Yeah, the practical benefit.
I think the practical benefit is you're very much at the point where it's a battle between you and Pareto, and you're losing. So, for example, Fabrice Ballard, like FFmpeg, etc. He wrote he has a library called libnc, which is basically a C only plus CUDA, which I guess isn't C, automatic differentiation library, and he at one point had the record for one of these compression benchmarks, but then he started fighting for it, and then you'll notice that it can compress on any machine, but you have to be on the same hardware to decompress. So they're very much in the fighting over small wins in the hope of discovering interesting things about how these models work and learn and also insights into how to overfit the data set and so on.
Yeah,
But they're not training generic with the some of these benchmarks. They're not training a generic like model that compresses. Is the kind of the rub. So it's very much not aimed at improving, I don't know, like improving network throughput or something like that. Like Z standard is very good. It's genius.
Yeah, it's a good thing to see if we can go even further in terms of research on that part.
All right, that's it, guys. Thank you, Max.